In this video, we will show you how to create your first project with SAMD21 using MPLAB Harmony version 3. If you are new to Harmony version 3, be sure to watch our video, How to Set Up the Tools Required to Get Started with Harmony version 3. This project is based on the SAMD21, our Cortex M0 Plus microcontroller. For this video, we will use the SAMD21 X Pro kit that contains the SAMD21 J18A microcontroller. This kit has an onboard EDBG debugger. Our goal in this video is to send a Hello World string to a serial terminal window running on a computer. To achieve this, we will create a project, configure the clock settings, configure the peripheral library to configure the serial communication USART. Serial communication, shortly called as SERCOM in the SAMD21, can be configured as USART, I2C, or SPI. We will configure the SERCOM as USART using the MPLAB Harmony Configurator, a GUI-based tool. We will also help you to configure the pins, and then compile the project and see the output. To get started, launch MPLAB X IDE. In MPLAB X, select File, New Project. In the New Project window, select Microchip Embedded in the Categories window and select 32-bit MPLAB Harmony 3 project in the Projects window. Click Next. In the Manage Framework section, enter the path in which the MPLAB Harmony version 3 packages are downloaded. Click Next. Under the Name and Location section, Location indicates the path to the root folder of the new project. All project files will be placed in this folder. The folder field indicates the name of the MPLAB X project folder. Here I have entered Hello World. The Name field indicates the name of the project. This name will be displayed in MPLAB X IDE. The path information will be updated as and when users make changes to other fields. Click Next. In the Configuration Settings section, enter the configuration name. In the Target Device dropdown, choose the MCU. Here we will use the SAMD21 J18A. This is the MCU available on the kit we plan to use. Click Finish to launch the Harmony Configurator, or for short, MHC. Before launching MHC, in the Configuration Database Setup window, you need to configure the Device Family Pack, or DFP, and the CM syspath. Click Launch and the Harmony Configurator plugin will open. Please note that, for this video, native NetBeans mode is used for the MHC window manager. You can change to this mode by clicking Tools, Options, Plugins, Window Manager, and selecting it from the dropdown. Click on MHC, Tools, then Clock Configuration to launch the Clock Easy View window. In the Clock Easy View window, you can configure the clock. Here we will use the default main clock that is set to 48 MHz. To add and configure the SERCOM USART, under the Available Components tab, expand Peripherals, and then expand the options available for SERCOM. Double-click on SERCOM 3 to add it to the project. Select the SERCOM 3 peripheral library in the project graph. In the Configuration Options window, make sure the SERCOM operation mode is set for USART with internal clock. Clear the Receive Enable checkbox as the string will only be transmitted. Set the baud rate to 9600. In the Transmit Pinout section, choose SERCOM Pad 0. To configure the USART pin, in the Harmony Configurator, select MHC, Tools, then Pin Configuration. The Harmony Configurator Pin Settings window will display these options: Pin Diagram, Pin Table, and Pin Settings. According to the SAMD21 X-Planed Pro Board schematic, the onboard embedded debugger can be used as virtual COM port to have serial communication between the SAMD21 device and a connected computer console. Therefore, in the pin settings, the PA22, pin number 43 of the SAMD21, must be configured as USART_TX. In Harmony Configurator, under MHC, click on Save State to save the state before generating the code. Save the configuration in its default location when prompted. In the Generate Project window, click Generate to generate the code. You can go to the project configuration path and check the generated files if needed. For our project scope, add the following code in the main.c file as shown here. This code here will define the string to be printed and send the string. Connect a micro USB cable between the debug USB port on the board and a PC. This enables the programming of the microcontroller and provides a serial connection with the console device. In MPLAB X under Project Properties, select the SAMD21 X Pro as the target kit in the Connected Hardware Tool dropdown, and select the XC32 version 2.41 in the Compiler Toolchain window, then click OK. Open a serial terminal application, such as TerraTerm, on the PC and perform the serial port setup. You can now build and program the SAMD21 Explained ProKit by using the MPLAB X IDE. Here, you can see the Hello World string printed on the console. If the desired output is not found on the console, press the Reset button on the X Pro board to reset the device. Finally, we have provided some useful reference web links. Here is the MPLAB Harmony landing page, where you can find all of the information about Harmony version 3. These are web links to some of the Getting Started collaterals available on our site, which are related to this video content. Thanks for watching.